Technology Services here at the library who will be presenting this webinar. Over to you, Wouter.
Thank you, Gertner. Appreciate it. Yes, this is our fourth presentation in the session for Let's Driving Research Impact with Emerging Technologies. And I'll be presenting some thoughts on navigating generative AI opportunities in research. I'm just going to share my screen. And I'm going to get my presentation going here in a PDF format. You can all see that, hopefully.
Yes, we can see your screen.
Good. I'm going to, as Kirchner said, my name is Wouter Klapwyk. I'm the Director of Information Technology Services at the Library Information Service. In this portfolio, we manage the library's digital systems, the network, and we're obviously exploring opportunities in applying artificial intelligence to enhance the services for our students, and also in making the library's operations more efficient. So our presentation today will be a bit different than the others we've had before. As a quick introduction, we'll be focusing on generative. I'll be doing an introduction to generative AI within the context of research. And then I'll also be explaining some large language models fundamentals from a data and a model perspective. And then we'll run through a couple of practical examples to use generative AI for idea generation, getting data and analyzing data. And we'll be using ChatGPT and Gemini for this. And our discussions will refer to only the following AI-enabled tools. Obviously, it's ChatGPT itself and Google Gemini itself. We'll be using Google Gemini within Google Colab. And I'll aim to quickly display some code output generated within Google Colab by Gemini within RStudio. At this point, I should mention, and it was mentioned in the previous presentation as well, that there are many AI-enabled tools that you can use for teaching, learning, and research. And the university is not currently in a position to formally support a specific tool, but neither in a position to prohibit you from using a specific tool. So I'm going to keep focusing just on ChatGPT, Google Gemini, and RStudio, because these are commonly accessible tools. And I'm not going to refer to tools like Julius.ai, which is a very good one and for which you can get university subscriptions as well, which basically combines Excel, Python, and ChatGPT into one. If you're not familiar with RStudio, you can go to rtutor.ai and you can use ChatGPT within rtutor.ai to explain to you how your R code works and teach you how to use R. So RStudio is a package which is freely downloadable. You get a server version and a desktop version. I've installed the desktop version, but you can use also the R2AI tutorial. Okay. As an introduction, I just like to again focus on the growing global AI optimism, specifically in research. AI's had a great impact on new research breakthroughs, specifically lately in two Nobel Prizes, which recognize the work that led to deep learning, physics, and its application to protein folding in chemistry. So according to the Stanford University's AI Index report, there's a growing impact of applying AI within research. But there's also a limitation. AI still fails to reliably solve logic tasks because it works on a predictive nature, and we'll quickly just discuss that again. And I know this has already been said so many times before, but it still remains a very important point. So it still struggles with very complex reasoning tasks, although it's improving, and specifically logic tasks. Like I said, if we look at the different benchmarks for that, the blocks world and the mystery blocks world, those are benchmarks for measuring or assessing the accuracy of AI in reasoning and logic tasks, and the results aren't always as good as we still would like them to be. Then within a more global perspective, different countries have to find a balance between innovation and caution in applying AI. And all countries are in a different trajectory when it comes to this. So when we are faced with something which is new and which disrupts what we do, we have a situation where we experience fear, and we need to balance that off with creativity. Fear regarding the unknown, and creativity to be applied in order to address how are we going to traverse this new uncertainty. And in humans, the fear and the creativity are processed both mentally in similar ways. So obviously, there's a constant debate about to what extent you need to be progressive in applying AI and what extent you need to be cautious. So I thought I'd just put this slide up to indicate here. South Africa, I'm not sure if this is visible, we're about neatly balanced here between being very innovative with applying AI and being very cautious. And it's interesting, the United States, even though they're so progressive with their AI developments, on a global scale, they are still being very cautious, where China, right up there, they're being a bit less cautious and a bit more progressive in its application. So this is in the application of AI rather than in the developments of AI. So we're not in a bad spot globally, South Africa. We're being cautious, but we're trying to be innovative in its application as well. But I'd like to just quickly give a broad overview of the different AI models, because we're focusing here on generative AI. And as a revision, you get 3 broad AI models: the symbolic, the connectionist, and the generative. And the symbolic is the original AI developments which focused on logic programming through rules and answers. It's also embedded in knowledge organization systems, which libraries, for example, rely heavily on, thesaurus, ontologies, classification, taxonomies. And then the more later developments are purely statistical based, analyzing the probabilities in which something can be true through statistical methods. And so you're connecting different data points to make a prediction through machine learning techniques, and that is connectionist AI. And then taking that forward into the generative AI space, just through the application of much more data, we get context-aware data analytical methods. And through that, you can determine how related two things are to each other within a big data space as such. And that allows us to make word predictions, for example, and that is the more generative AI space. But I would like to simplify things. I just want to throw away the symbolic AI. Because essentially what we're dealing with these days is only connectionist or machine learning AI and generative AI. But in doing so, you need to understand there's now no more logic or certainty. We can only now deal with probabilities, because we don't have very explicit rules saying one thing is true and other thing is saying other thing is false. So the difference here between the remaining AI models, we're going to just rephrase connectionist AI and generative AI slightly by referring to them as machine learning and language generation. That leaves us with the question what we can do with Gen AI in research. So essentially are two things which we want to focus on today, what we can do. The one is to do idea generation, but not to do idea generation by putting a prompt in a language model and asking it to write something for us. Rather, what we're going to do is we're going to take a data file, give it to the large language model, and ask it to analyze it and help us create some hypothesis from it. So we're working from a data perspective rather from a writing perspective. Good. So, all right, so I'm going to have to move it on a bit faster because it seems I've lost some time. So essentially what we're saying is we use generative AI to explain in a normal language a machine learning system to generate code in order to analyze a data file and develop code for us to do an analysis on the data file. It's just a different approach to using generative AI to write something. So in order to generate text, we need essentially a data and a model. So if you want to know what's going into your large language model, you can go to a website called lifearchitect.ai and ask it what it is in your specific AI, whether it's Grok, GPT, or Gemini, and it will explain to you more or less what your large language model is made up of. So for ChatGPT 3, for example, it gives a nice explanation of all the different media outlets and databases and the common crawl database it used in order to build and train its data model. So it gives you a good downbreak of what's in it. Obviously, this is having a bad impact on publishers as well, because these large language models are taking traffic away from publishers, because the users are not getting the information from the publishers, and this is a big development in the publishing world. And from this, there's also new opportunities have arisen by companies who simply monitor the logs of the different content providers, like news outlets, to see are the different large language model companies crawl their data, and then they build them automatically based on that crawling of the data. They build the large language models companies, and some of these companies that do this for a living, they're already billion-dollar companies, and they've only been in existence for the past 2 years. Just gives you a good idea of how much data has been scraped from the internet. Going forward, it seems that we won't even have to be instructing our AI models to crawl specific databases. Rather, new developments in Google's DeepMind deep research unit is now going to allow their crawlers to crawl autonomously and decide on their own which data to scrape, rather than use human judgment to instruct it where to go. In terms of a model, we do know that large language models work on pattern predictors and built on neural networks with the attention mechanism. So I won't stand still on that too much. But we do need to understand that from a model, the model is only an abstract description of reality. And the best way to look at the model from a language perspective is to consider that we need to combine 4 models to disambiguate properly when we need to understand something. We have the world model, the likelihood that the proposition will occur in the world; the mental model, the likelihood that the speaker forms a certain intention of communicating something; and a language model is basically the certainty that a string of words will be chosen. And that's essentially really what a large language model does. It predicts the next chosen word. And these models have developed over time. To the left of the line, we have the symbolic methods, which were rule-based. To the right, the more statistical approaches, which were based on machine learning and now on generative AI methods. As an extra, if you wanted to know how to customize a large language model, you can do it in 3 ways. And rather than just use it, but to customize it, you can fine-tune it by choosing a base model, implementing it on your own hardware. It is very hardware intensive. And then retraining it on some of your own data. Second way of doing is implement a retrieval augmented generation system, which basically takes a large language model and you supplement it with your own data without retraining it. And that data goes into a separate database which you maintain. Obviously, before that data is fed to the large language model, it is vectorized or embedded as such into the same data structure of the large language model. And the third way, which is essentially what everybody does, is to use prompt engineering and specifically a few-shot learning approach to give a couple of examples to a large language model to teach it exactly what you are trying to ask it by focusing on your topic and the way you would like it to answer. And then in terms of hallucinations, it's just a matter of probabilities. This picture was created by ChatGPT by instructing it to generate a picture. A cat chases a pink elephant, and ChatGPT obviously determined that the probability that a cat will chase a pink elephant is 0%. And therefore, the output generated by the language model was a pink elephant chasing a cat. So it's a matter of this is a hallucination, because the probability of what you want is so low. I'm not going to explain the probability on a reciprocal graph because we don't have the time for that. So just moving on. So it's important for us to separate the language capabilities from the knowledge. But just once again realizing, as what mentioned in the previous presentations as well, that large language models are language models and they're not computational models. They don't know things, they only produce convincing text, but they don't know things for a fact. Good. So in terms of a couple of examples, how to generate ideas in research, the most common approach is scaffolding with systematic reviews and meta-analysis. You can essentially get a list of 5 or 10 recent reviews on your topic of research. You can upload them as PDF documents into your large language model. And you can ask it to analyze the documents and give you a hypothesis of what is written in those documents. Systematic reviews is a detailed topic on its own, and we're not going to discuss it here further. And there's also some evidence to the fact that you shouldn't totally rely on AI for systematic reviews only. So we're not really discussing scaffolding here as an idea generation. But what we are going to do is just quickly look, how can you upload a data set first and then describe it in detail using normal language. It's a useful add-on to help define what the data actually does. But obviously, as you would think, there's a risk of hacking in doing this. You take an existing data set, upload it, and ask it to do an hypothesis on it. It will actually be doing a hypothesis on data after research is already known. So there's always a risk in doing so. So I'm going to basically just switch screens here. Go to ChatGPT. I'm not saying this is not something you have not done before, cells, I'm just going to simply upload a file, and can upload World Happiness Report, and I'm going to ask it to describe the data file in natural language. And it will basically tell me exactly what's in the file. Obviously, I can see that for myself, but it will give me a full description of what's in the file. So wait for it to finish before we ask it the next thing. So without having to do too much analysis myself, I can just simply ask in normal language what's in the data file. And then I can ask it what theories can I test with this. Just to sort of, in terms of idea generation, to see, given an existing data file, what theories can I derive just looking at data, and to prompt my ideas in terms of my research. So, but based on a large language model's knowledge, it gives me a couple of ideas how I can theorize on the data within the file, and then I can go and say, okay, I've got this answer, write the barcode. To upload the database. Okay, and test it. So if I want to take basically that data file and I want to analyze it further in R, I can just instruct it to write me the R code. And what ChatGPT does, it does text prediction, but it does it specifically for coding. Now, doing a text prediction for coding is much more accurate than doing it to write summaries or abstracts of data, because code is much more explicit and structured. So you know that the code it will give you is very accurate. So I'm going to copy this code. Okay, let's copy it. I'm going to go into R, and I'm going to essentially just copy it in here, paste it, and then I'm going to, I need to obviously run it, but sorry, let me just do it slightly different. It's only R script code. I'm going to run it. I think what I need to do is I need to give it the correct path for my data file. Let's see. Let's see if I can run that. Let's see. Okay, it's not giving me a correct result there. I do have the correct path to the data file. So there's a problem with that. For some reason, it's not finding it. Let's correct that. Okay, so fine, it's giving an error there. But hypothetically, if it did read it correctly, it would generate a graph on my hypothesis, which I generated in ChatGPT, and display the graph within R. So I can basically combine my data analytical package, R Studio, with a generative AI tool like ChatGPT to generate the code for me in order to analyze a file and display it to me. It's a different way to use generative AI than just asking it to generate text for a article you're writing. Okay, fine. So just moving on. A great technique which you also can do is to, if you're starting out with your thesis, is to make up a data, to write up your entire paper, and then swap out that fake data with real data. And in the process, it will allow you to start writing and experimenting with the data and the topic immediately. So essentially, what you can ask your AI to do is to create a data set for you using different prompts to create the data for you, to create the data set for you in R. So you can prompt it to create a data set for you with fake data. Then you can start writing your research article by having some data at hand. And then you can, once you've done your research, you can swap out that fake data with the real data to do your final analysis on. So having some data at hand which you have not collected yourself might help you in terms of structuring your research and doing your research before you do your actual final real-world data collection. That's just another way in which generative AI can assist you in doing research. All right, so then another way which we can use generative AI is to basically transcribe data. So what I'm going to do is I'm going to go to Google Colab, and use Gemini to ask it to transcribe some data for me. All right, so let's say we want to, I'm just going to delete, I can keep that. I'm going to delete this. I'm going to tell Google Colab to generate something for me. I'm going to tell it I need a simple code that reads an audio file and transcribes it. And I'm going to hit enter. So it's generating the code for me. And I have a sample audio file already uploaded. Okay, I need to upload it again. It's not there now. I have one here at hand. It's this harvest one, harvest audio file. It's uploading it for me. And then I'm going to say copy path. And I need to quickly find the place in this code where it reads the audio file. Should be there. So let's Right. So this location is the audio file location within Colab. And I'm going to run the R script. So what it's doing, it's downloading all the different packages, and then it will transcribe that audio file for me. Okay, I need a requirement. So let's see. Problem with these things doing it live is there's always a problem creeping in, and it doesn't work. Okay. So unfortunately that I can't debug this fast enough. If it were to work correctly, it will transcribe the audio file for me, and at the bottom it will tell me exactly in text what it is in the audio file. So I can then use that text and see what is in the audio file. And so if you want to download a lot of data from YouTube, for example, you can use this method to automatically transcribe a lot of data for you by not knowing how to code, but using generative AI to generate the code which does it for you. Just a different way of working than buying a transcription piece of software to do that for you. Okay. Sorry about the fact that it didn't work quite correct. I tested it just before my presentation and that. Okay, just continuing from here, I don't have much more time in any case. To conclude, basically, there are three main considerations which you can use to use AI tools in research. The first one is you can group AI research tools into two broad categories. You can use it as general purpose tools, and this is what we mostly do to date for ideation and for double checking our grammar. And then you can use it for task-specific tools, like deduplicating papers in literature reviews, the discovery of information resources. And if you use it as a general purpose tool, you can use it specifically as an assistant, like I'm trying to do here. Unfortunately, some of the practical examples aren't working exactly in the code. It does require from you to get to understand and interpret code a little bit over time through experience. Or you can use it as a model. Basically, you use an API to call the large language model and send it a prompt to do sentiment analysis on. And like I said, you can add capabilities to you can't add capabilities to GPTs, but you can add data. Okay, and some of the data you can add is textbook content, limited data, and custom prompts. As I explained in some of the previous slides, how to customize your large language model. Essentially, we're looking at supporting research with large language models through commercial chatbots, which is the closed model, and using it for writing support, fact-finding, and prompt engineering. And this is where we are pretty much at Stellenbosch University right now in terms of all the offerings we're giving students and the recommendations we give students to how to use a large language model. It's through a closed model like ChatGPT or Gemini, and we use it for writing support, fact-finding, and prompt engineering. But one would like to see in time we move to the area of learning and research support, with great expertise in supporting large language models for research. And then as a much further advanced stage, providing publishing and shared resources for using large language models in research. But we're not there yet. Now, as a closing, education has a current AI trust deficit. And I think this came out very strongly also in a previous presentation by Lennox Oliver. Students lack trust that their institution's faculty members will be clear, consistent, and transparent with the expectations on how to use AI. And then the faculty lack trust that the students, when able to access such a powerful technology, will use it in ways that are ethical and honest about their efforts. So there's a disconnect here, and it's a disconnect we're all very aware of, and it's one that we need to traverse collectively, and over time find a better common understanding how we can apply AI within academic environments. But the technology providers have put a wedge between the students and the faculty by emphasizing tools without guardrails on the one hand, and offering only opaque AI detection solutions on others. So many of the tools which are made available to us aren't always that helpful, because we can't say for sure on which models they were built, which data was used to train those models, and this information which we need in order to underwrite or underscore a tool or support a tool is not always available for us as universities. Hence, my recommendation to rather use the more commonly accessible tools like OpenCollab and ChatGPT and Google Gemini. Like I mentioned in the beginning of my presentation, with existing machine learning tools like RStudio, to ask a chatbot to analyze a data file and generate code in order to analyze it for you and to visualize the results of those data files for you in a more secure and AI ethical way. Especially given the fact that AI generates code in a very trustworthy way, because code is very structured and has a limited syntax. Okay, so that's my story for today. I apologize for the fact that some of the code executions didn't work very well. It's always a risk when you do presentations of this sort, but I'm happy to take questions, if any.
Good afternoon, colleagues. Kirchner had to excuse himself from the meeting, so I will read the questions to the presenter on his behalf. The first one is a comment from Mr. Mkize, and he says, I've been successful in transcribing directly from YouTube video linking using Google AI Studio.
Yes.
And then yes. The next comment in the chat, I think it's a question, this one rather. What about South African English accents? I found that some of these applications cannot hear our accent.
Let me just quickly take those two questions or two comments. Firstly, yes, the Google AI Studio is an excellent tool to use to transcribe data. What you can do is you can get a Gemini API through the Google AI Studio, and then you can use that to plug into Gemini. So I did not cover that in this presentation, but that's one I've used before. In terms of the South African English accents, I think if you use the correct transcriber AI plugin, in Python, then you get good you get a good return rate or good success rate on South African accents. And I'm thinking specifically of the Whisper transcriber AI plugin. Now, Whisper was developed by OpenAI. They developed it for themselves in order to transcribe all the YouTube content they downloaded, and they obviously downloaded YouTube content from people who presented with recorded in French accents, South African accents, Chinese accents, etc. So it's well trained on different type of accents. So depending on what the transcriber plugin you use, you might get better results than on others. But I would recommend the Whisper.ai transcriber Python plugin developed by OpenAI in order to transcribe all the data they scraped from YouTube and train their model with.
Okay, thank you for that response. And then the next question is, how safe / ethical is it to upload data to ChatGPT even if the improve for all is switched off?
I think it's safe. You need to trust these large language model companies at some point in time. And what I'm also trying to achieve here with this presentation is to counter the default mistrust we have in generative AI and reasonably reputable companies are behind it to a certain extent. They are bound by law to adhere to your wish to keep your data private and not to use it to train your own model if you upload it for further analysis through the model. So I would trust that.
All right, and then Bronwyn wants to know, should higher education institutions be proactively working with technology companies to create AI tools?
I wouldn't think so. It's a large industry which requires an enormous capital outlay in order to build a large language model, purchase all the hardware which needs to be used to train the data, with people in high expertise to do all those tasks. I think higher education institutions should more reflect on the ethical and philosophical questions regarding AI developments, and teaching students to use them in a responsible way, and teach them the fundamental underpinnings of what they rest on in order to understand what they're about and to assess for themselves how to use them appropriately. Working with AI companies to create these tools is a niche area and outside of the remit of universities, in my personal opinion, but that's just my opinion.
Okay, and Bronwyn says, thank you for that. The rest are just comments in the chat box. I just want to mention to the attendees that your microphones are now activated. You are welcome to unmute and ask questions directly to the presenter. I'm also handing over to Kirna to close this session if there's no any other questions.
I'm just going to give a second or two to see if anybody would like to ask a question with their microphones. Yes, Mr. Mkhize?
Hi, thank you for the opportunity. I just want to share my very quick experience with using AI. I use it quite a lot for my assignment, in particular When it comes to getting it to speed up some of the work that is not necessarily for your field. So I'm in the futures field, future studies. And in there, we also might do some work, for example, quantitative forecasting that we're being taught, how to do it from a futures perspective. But the actual data analysis is something that falls in the ambit of statisticians, for example. So something that we found and was encouraged by our lecturer is that if you do want to get some extra marks, you can go and actually process the data itself. And I've found that that actually does help in that instance where, for example, I did see that the presenter was using Colab, and that actually, was quite useful on my side to be able to process some of the data so that you don't just talk about, theoretical futures, how these might be, but you're actually able to process the data and see exactly what theories you were talking about. So for me, I think I just want to highlight and also emphasize what the speaker is saying, in that in us looking at this more as a threat, I think we're missing out on an opportunity to learn some of the skills that are outside of our discipline. Future studies is transdisciplinary by nature. And for me, I found that actually embracing the AI tool allows me to learn other disciplines that I might not be taught explicitly on my side. So that's just a comment I want to share on these things.
Thank you so very much. I think you summarized very eloquently exactly what I was trying to achieve with this presentation, is to look at the opportunities presented in generative AI, which you can apply in an ethically correct way, and knowing that the probability of hallucinations are very low, if not zero, by taking existing data sets, analyzing it, developing code, and to use that code to do further analysis on data sets to help you ask further questions in your research formulations. And also to create some fake data in order to help you to get going with your research, and then obviously swapping that fake data out with real life data at a later stage in your research. The opportunities are immense. We shouldn't just be focusing on the punitive measures for using AI to write text and formulate some ideas. Thank you for that comment.
All right. Does not look like there's any other questions forthcoming. So I want to thank Wouter for his participation in our Library Research Week. And I hope you all found value in the information that he provided, and to also give us a bit of a positive spin. And yes, we hope to see you at some of our other sessions that are still scheduled. All right. Goodbye, everybody.